How QR codes actually store information. Decomplicated. A QR code looks like a picture, but it's not a picture. It's data, arranged in a very specific way. Every black and white square is a choice. On or off. That's the foundation. Binary information. One square represents a bit. Many bits together form meaning. But a QR code is more than random squares. The three large blocks in the corners are position markers. They tell the scanner where the code starts, how it's rotated, and how big it is. Without them, the code would be meaningless noise. Between those markers is the data area. This is where information is stored. Text, numbers, links, instructions. But the information isn't placed directly. First, it's converted. Letters become numbers. Numbers become binary. Binary becomes patterns. Black means 1. White means 0. The data is then written into the grid, following a strict path, zigzagging through the code. Not for humans, for machines. You might notice QR codes come in different sizes. That's not design. That's capacity. Small codes hold little information. Larger ones hold more. These are called versions. Each version adds more rows, more columns, more room. But more space brings a problem. Damage. QR codes are printed, folded, scratched, seen through dirty lenses. So they plan for failure. Extra data is added. Not new information, but backup information. This is called error correction. It allows the scanner to rebuild missing parts. Not guess. Reconstruct. Even if up to 30% of the code is gone. The higher the correction level, the safer the code. But safety costs space. More protection means less room for content. Every QR code balances this trade-off. To help scanners stay precise, QR codes include timing patterns. Thin lines of alternating black and white. Running between the markers, they act like a ruler. They tell the scanner how wide each square is, where one ends, and the next begins. There's also something easy to miss. The empty white border. This is the quiet zone. It's not decoration, it's separation. Without it, the code blends into its background, and scanning becomes unreliable. Before the code is finished, one more step happens. Masking. The data pattern is altered. Squares are flipped, not to hide information, but to avoid patterns. Long lines, big blocks, repetitions. These confuse scanners. Masking breaks them up, making the code easier to read, even if it looks more random. Once masking is applied, the QR code is complete. It doesn't point to information. It contains it. When you scan a QR code, your camera captures the grid. Software finds the markers, measures the rhythm, checks the quiet zone. Then it reads the squares, repairs what's missing, removes the mask. Zeros and ones reappear. Data is decoded, meaning returns. A website opens. A message appears. An action happens. All from a silent image. No power, no memory, no intelligence. Just contrast, structure, and carefully designed rules. So when you scan a QR code, you're not opening a picture. You're reading a message designed to survive the real world. Thanks for watching. Did you already know this is how QR codes store information, or did something surprise you? If there's another everyday system you'd like explained, let me know in the comments. Till next time.